Hello everyone, my name is Julio Zayas and I'm going to present my poster named Effect of EX-SITU Sintering Time on the Optical, Ferroelectric and Microstructural Properties of Bismuth Ferrite Thin Films deposited by sputtering technique. Ferroelectric thin films exhibit various properties such as electrical, magnetic and optical. They are characterized by piezoelectric, pyroelectric, high dielectric constant and a photovoltaic effect. These properties enable these materials to be used in electronic devices. In this research, we deposited thin films of bismuth ferrite onto two different substrates and evaluated its structural, optical, and ferroelectric behavior. The targets we used in the deposit process were obtained by a modified solid-state route, and the deposit process was carried out by sputtering. These deposits were carried out onto two different substrates, which were glass and EX-SITU, and the deposit process consisted on three stages with different times, which were 10, 30, and 50 minutes. And a heat treatment was carried out between each layer of deposit at 550 degrees Celsius with different sintering times, which were of 15, 30, 45, and 60 minutes. TRX patterns showed that in all samples a perovskite type structure was obtained with a rhomboedral phase corresponding to the bismuth ferrite. And also it can be seen that in all samples a small secondary phase was obtained corresponding to the bismuth oxide. Also, it can be seen peaks corresponding to the substrate of FTO. Same image show a tendency of grain size decrease from samples of BFO 15 all the way to BFO 45. In these samples, a tendency of grain decrease is observed. However, for BFO 60, that is the sample of BFO with 60 minutes of sintering time, increase of grain size is observed. Atomic force microscopy revealed the roughness of the thin films, which were between the values of 21.4 and 12.1 nanometers. The behavior of ferroelectric domains was observed through piezo-response force microscopy, where the films were graven through the application of 8 volts with different polarizations, indicating not only the presence of ferroelectric domains but also their reorientation capacity through the influence of an external field. Lastly, the optical behavior was evaluated through the reflectance and transmittance spectra, and it can be seen that the optical bandgap is changed slightly with scintillating times, where the values obtained were around of 2.74 electron volts all the way to 2.75 electron volts. Conclusions. Sintering time does not affect the crystalline structure or phase of bismuth ferrite thin films. Grain size shows a tendency to decrease from 96.01 nanometers to 85.55 nanometers with sintering time. Roughness changes with sintering time with values between 21.4 nanometers and 12.1 nanometers. A ferroelectric behavior is observed in all samples through PFM analysis at ±8 volts. The optical bandgap of thin films changes slightly as the sintering time increases. Acknowledgement to CONACYT for its financial support, to Autonomous University of Sinaloa, and to Simvestab Unit Querétaro and all its auxiliary personnel. Thank you very much for your attention.